Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
All right, good morning. How are you all doing? Okay, in today's class, we'll be looking at differentiation, all right? And we shall be looking at the other aspect of differentiation. In our last class, extensively on other method of differentiation, we looked at the power rule, the quotient rule, the product rule, the implicit function, and so many other functions we considered. So today we shall be looking at other aspects. And here we have, right, on the table we have called differentiation what? Table. The first is called the power rule, Abi. The power rule says what? If I'm to differentiate this, what do? We multiply n by what? A, right? And subtract what? 1 from what? From the power of n. Isn't it so? Isn't it? We are all here, right? When I taught this, right? Then for this, the rule says whenever you differentiate sine x, the answer is what? Cos x. Right? This says what? If we differentiate cos x, we have what? Minus sine x. When we differentiate exponential x, what do you have? Exponential x. This does not change. If you differentiate exponential ks, what do you have? K exponential what? Kx. If you differentiate tan x, we have sec square x. If you differentiate log x, we have 1 over x. If you differentiate log x base e, is 1 over x log e base a. Cos x will give us minus cosec square x. Sec s is what? Sec s tan what? X. Sin hs is same as is what? Cos hs. If you differentiate cos hs, we're going to have sin what? Hs. These are the basic differentiation table that every one of you must be familiar with. Are you following? There are other aspects, but basically for IMSU students, these are the ones you should take note of. Now, can we now solve some problems? Shall we? Okay, example 1. If we are given y equals sine 4x cubed, and we have to find the y dx, how do we find the y dx? Look at this. Please pay attention. Stop writing and pay attention. Solution. Don't worry, I won't clean this part. Just pay attention. Are you there? We are given what? Y, Abi, equals what? Sine what? 4x cubed. The first thing we need to do is to look for a means to express this to be in this function of sine x. Are you following? This can be u. If I have sine u, what's the answer? It's still cos u. If I have cos u, what's the answer? Minus sine u. So I'll look for a means to express the whole of this to be in this form. And what do we do to that? We're going to say let what? Let u equals to what? Somebody? 4s what? Cube. I can use v, I can use w, I can use anything. But let us use what? U. If u equals 4s cubed, what will be your y? Y becomes what? Sine what? U. Let me call this equation 1. This equation what? 2. And what do we do? Can tell me. I will differentiate the u dx. Differentiate what? The y, the what? The u. Then multiply their products. Are you following? So let's differentiate the u dx. The u dx will give us what? 3. I will use power rule, right? Power rule says what? Multiply the power by what? Coefficient of x, right? And subtract what? 1 from the power. Let's go. 3 times 4 will give us what? 12. 12x raised power what? What is 3 minus 1? 2. We are done with this. Now let's differentiate the y, the what, the u. The y, the u will be what? If you differentiate sine u, what do we have? Cos. Are you getting it now? So when you differentiate sine, we have cos. That means the y, the u becomes what? Cos what? Cos u. Therefore, our dy dx, remember when we learned the chain rule, if we are given this, what do we do is to multiply the u dx by what? The y, the u, right? And that will give us what? The y dx. So our dy dx becomes the product of the u dx, the u, the what? The x, times what? The y, the what? The u. Do you know that the u can cancel the u, right? We are left with what? The y dx. So that means this expression is what? Is accurate. So that means our dy dx will then be what? What's that du dx? 12 what? S what? Square, right? Yes, square. Times, what is the y du? Cos what? Cos u. And this will give us what? 12s what? Squared. Cos. What's that u? So let u be what? 4s cubed. It means I will now replace my u with what? 4 what? S what cubed. Final answer to this. You can put it in all of you. So the y dx is what? 12s squared cos 4s cubed. Is that very simple? Simple, right? Okay. Okay, example 2. If we are given y equals to cos 4s cubed, and we have to find what? The y, the what? The x. The same principle, the same pattern we use in differentiating sine 4s cubed. But do you know there's a shortcut to differentiate sine 4s cubed? Do you know? The first one we solved. Let me show you the shortcut because it will really help you. So we will not be all the time, we'll not be passing through this process of co-function. Now look at this. If I have sine, let me show you the shortcut. 4s what? Cube, Abi? Are you following? The shortcut is this. Please pay attention. Just differentiate this using what? Power rule. What do you have? 12x, Abi? 12 what? S squared. So if I'm to differentiate this, we have this, right? What is your derivative of sine? Cos what? Cos what? I will repeat the same 4s what? Cube. Just like that. Differentiate 4s cube, we have 12s squared. Then differentiate sine, that will give us what? Cos 4s what? Cube. Is it clear? Now let's look at this. Y. If y equals to cos 4s cube, and we have to find the y the s. The same process, y equals what? Cos what? 4s cube, Abi? With the let what? U equals to what? 4s cube. So that means my y becomes what? Cos u. Equation 1, equation what? 2, right? So let's differentiate u. The u, the what? The x. Will give us what? 12s squared. What's our dy du? The y du give us what? Minus sine what? U. Don't forget that. When you differentiate cos x, what do you have? Minus sine. When you differentiate cos u, what do you have? Minus sine what? U. So that means my dy du is what? Minus sine what? U. Are you following somebody? So what's our dy dx? The product of what? Du dx, Abi? And what? Dy du. So our dy over dx becomes what? Du the what? Dx times what? Dy the what? Du. And that will give us what? What's that du dx? 12x squared, Abi? Times. What's that dy du? Minus what? Sine what? U. This will give us what? 12s squared. Okay, let's go. Let's go. Minus times this is what? It's minus, Abi? Yes, minus 12s what? Squared. Sine what? U, Abi? But what's that U? Somebody help me? So you have to do 4s what? Q. Are you getting the gist now? The same principle. The short form to differentiate y equals to what? Cos 4s cube will be what? You can tell me. Differentiate 4s, what do you have? Is what? 12s what? Squared. Differentiate cos, what do you have? Times minus sine, Abi? I will now repeat what again? 4s cube. Do you get the gist? So here becomes what? Minus times plus is what? So you have minus 12s squared sine what? 4s cube. Is it making sense? Oh yeah, please do what somebody? Second. Are we ready? I hope you guys are following, right? Now listen, pay attention. Here we are giving, example 3, we are giving y equals 12s squared cos 4s cube. And we have to find the y dx. Who can tell me what do we use to solve this? Product rule. Because we now have two products. We have 12s cube multiplying what? 4s cube, Abi? Don't forget, solution. Don't forget, I gave us a general expression for product rule that says what? If y equals to what? AB, right? Our dy dx is what? We keep what constant first? A. Differentiate b, right? The b, the what? The x. Plus, keep what constant? B. Differentiate a, the a, the what? The x. Meaning, don't differentiate a, differentiate b, Abi? Plus, don't differentiate b, differentiate what? A. So in this case now, 12s cube is what? A, Abi? This is what? B. Can we apply it here? So we are given y equals what? 12s what? Squared. Cos what? 4s what? Cube. Are you following? Now, the y dx becomes, this becomes my A, Abi? This is what my B. I have A, I have B. Now let's go. So I will keep one constant first. 12, Abi? 12s what? Squared. Differentiate cos 4s cube. What do we have? Who can remind me? Minus this, Abi? Hope you are aware. Are you aware? Differentiate this. What do you have? Minus 12s what? Squared, Abi? Huh? Sine what? 4s what? Cube. Is it not? Are you aware of this? Hope you know the golden rule here. Differentiate 4s cube. We have what? 12s squared. Differentiate cos. What do you have? Minus sine. Then repeat what again? 4s cube. Are you following? Then the rule says, what will be here? Plus, right? Plus, where is our daughter? Okay, let's go. Plus, we keep all constants now. Cos 4x cubed, Abi. Cos what? 4x cubed. Differentiate 12x squared. What do you have? 24 what? X. Can we expand this now? Let's watch. 12x squared multiplied by minus 12x squared will give us what? Minus 144 x raised power what? 4b sine what? 4x what? Cube. Are you following? Yeah, then here will be what? Plus 24x cos what? 4x cube. So between this and this, 24 is common here, also common here. Not just 24, we also have what? X as a common what? Factor. Isn't it so? So we have our dy, the what? The x equals to what? 24x in brackets. So if 24x is common, divide 144x raised power 4 sine 4x cubed by 24x. 4x. What's the remaining? 6x what? Cube sine what? 4x what? Cube plus what? What be here? Cos what? 4x what? Cube. Final what? Answer. Now example 4. Listen. 4i, 4ii, and 4ii. We are given that y equals exponential what? 5x squared. Here we have 4x exponential what? 6x cubed. Here we have 5 exponential 3x raised power 5. And we have to find the y, the x. Look at this here. If you differentiate exponential x, what do you have? X. If you differentiate exponential kx, what do you have? K exponential what? Kx. Are you following? This expression you are seeing here, this particular one, for instance, let's say we are giving y equals to what? Exponential what? 5x. I mean, this 5 represents what here? The k, right? What will be your divide the x for this? Is what? 5 exponential what? 5x. Is it not so? From this expression, if we are giving y equals to what? Exponential kx. To differentiate it simply means what? K exponential what? Kx. Your k in this case is what? Is 5. 5 exponential what? 5x. Is it making sense? Now, but there's another way you can solve this, of which I'll be teaching us now. Listen, please. Still, the chain rule method. The first one, we are told that y, right, equals to what? Exponential what? 5 what? X squared, right? Are you there? Now, look at it. Listen. This expression is not same with what? With this. Are you aware? Why? Because we have what here? Squared. Are you there? So I cannot say it is 5 exponential 5x squared. It's wrong. Are you following? So what we do is that I have two ways, but let me use the first method, which is the chain rule principle. Is that when I say let what? Let u equals to what? 5 what? S squared. If your u equals 5s squared, what's your y? EU and B. This equation what? 1. Equation what? 2. So we differentiate u and B with respect to what? To x. So we have the u, the what? The x equals to what? 10 what? X. Are you following? So differentiate what? Y with respect to what? To u. Meaning what? The y, the what? The u. We give us what? EU. Hope you are aware that if you differentiate EX is what? EX. EU is what? EU. EV is what? EV. So for this, differentiating y with respect to what? EU is still what? Somebody? EU. Therefore, our dy, the what? The x becomes what? The u, the what? The x times what? The y, the what? The u. And that will give us what? Let's go. What's our du, the x? 10x. Dot means times, Abi. What's the y, the u? EU. And that will give us what here? 10x exponential. What's that u? 5 what? 5 what? S squared. Do you get the gist? Do you get the gist? I just combine this with this. 10x multiplied by what? EU. And u represents 5s squared. Now, listen. Stop writing. The shortcut to this is this. These are shortcuts here. If y, can you all see the ball from here? If y equals to exponential 5 what? S squared. The shortcut, the y, the what? The x becomes what? Differentiate 5s squared. What do you have? Just bring out the 10x. Then multiply by what? Exponential what again? 5s squared. Is it clear? The shortcut. This is better, right? It's better, right? Now, number 2 says if y equals to 4x exponential 6x cubed. How do we solve this? I will use the product rule, right? Solution. Don't forget the product rule that says y equals to what? A, B, B. The rule says what? The y, the x equals what? We keep one constant. A, differentiate B, right? The B, the x plus what? Keep one constant. B, differentiate A, the what? The x. Now we are given that y equals 4x exponential what? 6x what? Cube. Are you there, somebody? Hello. So I will keep one constant first. So our dy dx, keep one constant is 4s, abi? Differentiate this, what do you have? Who can tell me? Differentiate this alone. This alone. What will it be? 18s what? Square exponential what? 6s cube. Are you seeing the shortcuts? How we apply this here? Are you there? Are you following? Plus, right? Plus, keep one constant now. Exponential what? 6s what? Cube. Differentiate 4s. What do you have? 4. So let's multiply through. Here we have what here? Here we have 4s. 4s times 18 s squared is what? 72 what? S cube exponential what? 6s cube plus what? 4 exponential what? 6s cube. Between these two men, what's common? 4, not just 4 alone. 4 exponential what? 6s cube is common. In brackets, hope you're aware. Yeah, you're aware. So when you divide the whole of this with this, what do you have? 18 what? S cube plus what? What will be here? 1. Is it clear, somebody? Oh yeah, please put this down. Alright, look at this now. Listen. Now here we are given y equals 5 exponential what? 3s raised to 5, right? What do you notice here? We have a constant value here, right? I can differentiate that, right? Differentiate 3s raised to 5. What do you have? 15s raised to 4, abi? Is it not so? That value you have multiplied by 5. What do you have? So my dy, the what? The x is what? 75 s raised to what? 4 exponential what? 3s power 5. Final answer to this. Or we can use our chain rule, abi? In your chain, what do you have here? Y equals what? 5 exponential what? 3s what? Raised to 5. Is it not so? Is it not? So we can use our product rule rather. What's our product rule here? We have A, abi? Yes, what? B. Is it not so? So what do you have? Let's go. The y, the what? The x says what? We keep one constant. 5. Differentiate this. What do you have? 15s raised to what? 4 exponential what? 3s, abi? Raised to 5. Are you following, somebody? Plus, keep one constant now. Exponential 3s raised to 5. Differentiate 5. What do you have? 0. Are you seeing the gist? So 0 times this is what? Is off, abi? So what do you have here? 5 times 15 is what? 75 s raised to what? 3 exponential raised to 4 rather. Exponential what? 3 3s raised to what? 5. Is it making sense? Are you there? Which one do you prefer? Second, abi? I don't know if you can attempt this question. Can you attempt for me? For your attempts, let me see your answer. I'm going around now. Hello, now listen, please. Pay attention and stop talking. Now, we are giving, right? We are giving what? Y equals what? 5 exponential 4x sine what? Sine x. Is it not so? Now listen, please. To differentiate this, we have to use what product word rule, abi? The product is between this and what and this, abi? 5 exponential 4s represent A, abi? This represents what? B. Is it not so? Are you following? Now you know the rule of product rule, right? The rule says what? Divide the x. We give us what? We keep one constant first. Your A, what's your A? 5 exponential what? 4x. Is it not? Differentiate sine x. What we say is the answer? Cos x, abi? We have what here? Cos x. Are you following? The rule says what? Plus, right? We keep one constant now. We keep sine x constant. Then differentiate what? 5 exponential 4x. I've said it before now that if I have a constant value here, I can do a direct what? Differentiation, right? Meaning, differentiate 4x, what do you have? It's 4. It's not 4. 4 times 5 is what? What will it be here? 20 exponential what? 4x. Is it making sense? Are you getting the gist? You didn't get the gist? From where? Let me explain. From here. from here. Keep this constant. This is your A. From your product rule, y equals to what? AB. Huh? This means what? The y, the what? The x equals to what? We keep A constant, right? We don't differentiate A. Differentiate what? B. The B, the what? The x. Plus, keep what constant now? B. Differentiate what? A. The A, the what? The x. So for this, if I have y equals to AB, what's our A here? This is our A, right? This is what? Our B. So the y, the x means don't differentiate A, meaning bring out your A. What's our A? 5 exponential what? 4x. Is it clear? Is it clear? Who I'm talking to? Is it clear? So in brackets, differentiate sine x, meaning B. The rule says what? The result is what? Cos x. That is it here. Plus this plus sign here. Plus keep one constant B, meaning don't differentiate B, right? What's that B here? Sine x. In brackets, differentiate this. The rule is what? I told you guys, I said, if we have 5 exponential what? 4x to differentiate. Are you there? Because there is no unknown value attached to 5, I can do a direct what? Differentiation. Like differentiating 4x, the answer is 4, Abi? It's not 4. That 4 times 5 is what? 20. So that will give us what? 20 exponential what? 4x. Which is this here. Are you there? Is it not? And that will give us what? Now that we have differentiated through, can we now multiply through? Let's go. Divide the x. Will give us what? 5 exponential, right? 4x cos what? X plus what? 20 exponential what? 4x sine what? Sine x. Between these two men, there's a plus sign, right? Between these two, what is common? 4x. So we'll bring it out. 5 exponential what? 4x. In bracket, if this is common, when you divide the whole of this with this, what do you notice? This will cancel this and be remaining what? Cos what? X. Are you following? Plus, divide the whole of this again with this. What's remaining? 4 sine what? X. Very simple.